Good afternoon, everyone. Welcome to NetworkX is Fast Now, Graph Analytics Unleashed talk by Erik Welch, NVIDIA, and Mridul Seth from NetworkX. The stage is yours.
Thank you. Thank you so much for coming to a talk where the main takeaway from the talk is actually in the title. So I hope we can make the next 30 minutes worth your while. I believe we can. So I'm just going to jump into a quick example of NetworkX not being fast and then being fast. This is a random graph of about 90,000 edges from 3,000 nodes and running it in NetworkX. So just a heads up, this talk is for everybody. So even if you don't know what a graph is, never heard of NetworkX, that's OK. We will circle back around and talk about stuff. So square clustering is an algorithm that somebody found very useful. Like they needed it. You see in the quote down here, the speedup was immense. I think we saved them days of computation time. And there's a way, so that took 25 seconds. And for computers, like 90,000 edges is not that much. It still took 25 seconds. For bigger graphs, this could easily take much more time. With a different backend, this run took about half a second, and this includes converting the graph. It usually runs faster, but hey, benchmarks are what they are. We trust live. This is running on the laptop, and the results are the same. So that is the NetworkX is fast now, but why does this matter? Like the Graph Analytics Unleashed, I work at NVIDIA, so I'm Erik, and making things fast is what we do. Like on the Rapids team, we are focused on accelerating the Python data science libraries. And I personally believe that poor performance of a library like NetworkX is what kind of prevents graph analytics from being a more mainstream literacy. It's still widely used, but people have to suffer through it. So I will introduce Mridul Seth. I want to do a quick story that we met 2 years ago at PyCon, where this whole kind of arc of this presentation began. And I spoke with him for hours over a course of days, and I am very privileged. I'm just so grateful that I am able to work on this from NVIDIA. That it's a win-win-win collaboration. NetworkX to me is like. So this is like a love letter, right?
Come on.
Like,
Yeah.
NetworkX is like the open source at its best. It's how the world collaboratively solves problems, and it's thanks to people like Mridul. So please take it away.
Okay. And I guess it's the same thing. Like 2 years ago, we met at PyCon. Like I think we knew of each other, but we never really worked together. And this kind of came out of that. And I'm a co-developer of NetworkX, and a lot of this work was possible due to a grant from Chan Zuckerberg Initiative. So for the last 2 years, I was doing NetworkX full time, living my dream, woohoo! But now I work with neutrons. This is not about neutrons, but let's move. So why do we care about graphs? So if you are in this talk and you don't really know what NetworkX is, you just wanted to see something go fast, it's fine. Let's talk about graphs now. And the first question is, do you have any data? And I think like a lot of people are working with data today, and data is getting bigger. And there is this one problem with current analysis tools in data that I think, and just in my opinion, my biased opinion, that people kind of forget about looking at the data as a graph or there must be some relationship between all of the data points. If you look at a data set as a spreadsheet, as a pandas data frame, as a SQL database, you know what to do with it. But usually you stop at that point and you kind of forget about, what if I try to model my data in a very different way? So this is what I'm trying to sell you here, is that maybe if you try hard enough, anything can be a graph. So and it will give you certain insights in your data that you would not get if you were just treating your data as just a block of code or a block of data on your screen as a data frame. And it's used everywhere. It's used in fraud detection, recommended systems, like who's your friend on Facebook, who you should connect on LinkedIn, graph neural networks. So it's used a lot. And like once you have, so I've sold you on the idea of, everyone should be using graphs and network science when they're analyzing their data. What do you need to work with graphs? So if today I have like spreadsheet-like looking data, I know what to do. I either go to pandas, or if I'm cool, I'll go to polars or DuckTV, and you know what to do there, right? It's because we have these really nice libraries out there that are easy to use, well documented, they kind of scale, and they're easy to install. You do pip install, conda install, it just works. So this is what we need to make a good data analysis library. And what's that for graphs? My pitch is that's NetworkX. And it's not just my pitch. It's LLM is saying that. I don't control an LLM. And what they say is the right thing. So for example, if you go to any of these LLMs, and if you ask a graph question, this is my network. I want to find some coefficient or some metric. How do I do this? At least with ChatGPT, it would actually print out a block of code, which is NetworkX, and it uses that. And see, if ChatGPT does it, who am I to question it? So, and that's the pitch here, that NetworkX is that answer of a well-written and easy to use front end to your graph analysis problem. So it's pure Python, and that's important to remember. It's pure Python, and we'll see what happens because of that. And it runs anywhere where Python is supported. So if you, it doesn't matter if it's an HPC cluster or just your iOS phone, because now you can run CPython on iOS. So it runs anywhere where Python runs. It has zero dependencies. You can depend on NumPy, SciPy, but inherently it has no dependencies. It's pure Python. And I like to believe it's well documented. It's excellent APIs, and it's open source. It's community governed. There's no company behind it, and it's an old package. It's almost 20 years old now. Used a lot. 50 million downloads on PyPI every month. So I'm trying to sell you NetworkX here. And to be fair, there are other tools out there in the Python world too, which do similar things. But people have different flavors of working with things. All right, and I'm trying to pitch you why NetworkX is the best thing in the whole world. And the reason I think is simple things are simple. I won't read the code here, but the idea is that how do I go from this image on right to code, and how do I find things like shortest path? I want to go from node A to D, and how to do this. And I believe that the API is very intuitive, and it just works. And that's the best thing, I think. But all is good, and everything works, but there are some problems here. So what if I don't have a small 4-node graph? I have a billion nodes. I have a trillion edges. What do I do then? Right? And as in the very first notebook example that we saw, from 25 seconds to milliseconds, that's a big jump, right? So this is where the problem comes in of pure Python. Perfect. It does the job very well for what it is designed to do, but when your data gets bigger, then that's the problem. It kind of creeps up, and it's 20-year-old. So it was written in an era where a single processor was okay, and most of the Python code was written to be bound to single processor. And at least till now, we don't really have a good story of do effortless multi-threading in Python. So, and this is where this is what we need to solve here. So, how do we fix this without losing all the good things that we love about NetworkX? Any ideas? No. So that's the first thing that we came up with. I came up with. Let's rewrite everything in Rust, and it seemed to work for everyone, right? Right? No, let's not do that. Let's not do that. A simpler idea that was dispatching, where as NetworkX, we control the front-end layer, and someone else can come in, like the NVIDIA GPU folks, and they can write an extremely efficient back backend, which we can dispatch the computation to. And like while all of this was happening, like the Rapids team already have their answer for this called cuGraph. And then as we met at PyCon, and then we started chatting about this, and something like this came out of that. This is like the grand evil plan where NetworkX kind of becomes like the graph API layer. So you may have heard about things like array API, data frame protocol. So my pitch or dream here is to maybe there should be something like the Graph API, where it doesn't even need to be NetworkX. It's just like a standardized API layer where people can write their own backends. So for example, right now we have something called NX cuGraph, which is for working with GPUs with cuDAP. Then there's also GraphBLAS algorithms. It's a heavily optimized CPU implementation of certain graph algorithms. Then we are also working on something called NX parallel, which is just rewriting a bunch of our algorithms that we have in a parallel fashion using joblib. And then there's also this idea that you can just use SciPy sparse as a data structure itself, and you can create a backend out of it. We haven't started. Like I made a POC of it, but if someone wants to do it, please go ahead and do this. So some other benefits of going this route is, I think, especially if you're a backend implementer, you get a lot of these things for free, which is hard to do in if you want to make a good open source software, it's not just put it on GitHub or GitLab or put it on the internet. That's usually just the first step, right? So the second step comes in that you need to make sure that you have good examples. You need to make sure that you have good documentation. You need to make sure that all of that fits very well, right? And usually that could be that's time-consuming work. And if you're someone who's usually an academic researcher, you don't have the time to do this. You don't want to spend your time doing this. You just want to come up with a highly efficient implementation of a certain algorithm and publish a paper and just be done with it. So how do we merge these things with something like NetworkX? So that's how this standard graph API plan is working in my head. It's not a formal plan, by the way. It's just in my head, and other people can disagree with that. So, but the idea is that you should be able to build your own backend and just plug into NetworkX. So all of the users, the 50 million users that we have, not users, but 50 million downloads that we have, they can use them too. And now I would like to move to Erik, and he'll talk all about backends.
Thank you. And as a backend developer, I really just want to belabor this point that all these things in bold, the tests for free, the docs for free, the API for free, it is like developing in cheat mode that I just write the algorithm and then I'm done. There's nothing else I need to do. And so there are 3 usable backends right now that are open source. And I think it's totally reasonable, if a researcher implemented one algorithm that they need to share that with the world by, so it's really a pleasure where all you do is I write the algorithm that I want and boom, it's done. I've been working on the GPU accelerated backend for NVIDIA as part of the Rapids. And we like to make low to no code change GPU acceleration. This means different things for different libraries. And this is a way we could do this with NetworkX. And I have a script in yellow where we load a data set with pandas, we convert that to a NetworkX graph, and then we run this between centrality, which is a measure of the number of shortest paths that go through any given node. It can find sensitive points in a network, or the most important points for transportation, for example. And so the timer on the gray box, the first one, we just run the script. It's an IPY file, and we have the time, so it shows the time of between centrality. It's just NetworkX. It takes about 8 minutes. We set an environment variable for setting the backend to cuGraph, and the between centrality runs it on the GPU. And this includes the conversion to the GPU. But it's really great that libraries that use NetworkX, applications that use NetworkX, you don't need to write custom code. You can say set this thing, and then boom, it's faster. So whether or not you have a GPU, that you can always like fall back to the GPU if it's not available, or opt in. And these benchmarks, and most of the benchmarks I'll be showing, is on the Quadro RTX 8000. This is a GPU from 2018. I thought it would be more fair to show benchmarks of a GPU that you may actually be able to get. At the end, I do have some H100 benchmarks if you want to see. This slide is a bit more detail about showing between centrality with different levels of K. K is the initial nodes you start with, and like you run shortest, the all pair shortest paths from this, and so you can see that the NetworkX times in the first row scales about linearly, like K equals 10, 100 seconds. K equals 20, it takes twice as long. For the cuGraph, there are two rows. One of them includes the conversion to the GPU. And we see that conversion probably takes about 10 seconds. And going from K to 10, K to 20, 50, 100, it's all about the same time. And so like we're not saturating the GPU yet. We're dominated by the conversion time. In NetworkX 3.3, we added the ability to cache graph conversions. So if you run an algorithm once, we can keep the converted graph on the GPU, and this is what the third row shows, that if you've already pre-computed the graph, or you start with just the next cuGraph graph, no conversions, then it's even faster. That row is like between the 100 or the 86 times to like 750 times. And like 700 times, like that's real pain. That goes from like minutes to seconds. This is just a sample of some of the most important algorithms that have been requested. This is what we implement in the next cuGraph. We're adding more every time. So centralities are common. Community detection is very, people like that. So I will hurry up to save some time, but we have some more benchmarks, again, like showing the NetworkX time compared to like, okay, converting and run the algorithm, and then like the algorithm without converting. Some of these are like 1,000 times faster or more. Some algorithms, like if you need to convert like weakly connected components, that the conversion time is not worth it, and so you should still be aware of like what you're running.
All right, so things are getting fast, super fast, and I want to stop talking about that for a bit now. And so like when we started working on this was all experimental work, and like we were just trying out things, and like it just worked. Like now we have a nice working, and it's not just a demo. You can actually go pip install things. You can use the backends, but another thing came out of it. So like we are right now trying to optimize implementation of the algorithms, but what about the data? So right now, for example, in NetworkX, the data is just stored as it's dictionary. Python dictionary is all underneath. It's dictionary of dictionary, and that's the data format. For example, if you are using scipy sparse, it's like sparse matrices. If you are using cuGraph, you have something, I don't know. And these are the different data formats. But like, what about all of this data? So like, does anyone know where I'm going with this? Database? Like, can we make NetworkX into a graph database? This was not part of the plan, by the way. This is like literally just like last 1 month of work, and again, just happened by chance that some folks from ArangoDB, it's a graph database, they started chit-chatting with Erik, and this came out, and then we realized that this backend system that we have come up with, primarily to make things faster, is now can be used for something like interacting the NetworkX API to a graph database. See, that means that we have created a new graph query language. That was not the point, but that's. But just to show a quick demo, and again, this is like this is just like a proof of concept. This is like 2 weeks old, and like on the left side, it's just you're doing some basic CRUD operations. So you're just like looking at the nodes in the graph. You're trying to remove some nodes, add some node, add some node attributes, like basic operations on a graph. And like in the NetworkX paradigm, it's like pandas. Like everything is happening in memory. Like once you close your Jupyter notebook or your Python process, all the data is gone. If you want to store the data, you would usually write it to like some data format file or pickle them. But you can also now, with this model, you can kind of like just link up your graph instance to a GraphDB instance. So your data persists now, and the code that you are used to writing with with NetworkX, you can kind of just keep on talking, and it works. And this was not part of the plan, so that's what makes me kind of very happy. So if there are any GraphDB folks in the room, please reach out to us after this. So like, where do we go from here? Like the first thing that I really would like appreciate is that if you use NetworkX today, and if you have complained about how slow it is, and we have heard a lot of those complaints, please try out dispatching and tell us what you think about it, what do you think about the user experience, what we are doing good, what we are doing bad. And we really need to work on better documentation, because over the last year we were just too excited about the implementation. So we are trying to do things better there. And if you want to help us, you can create an issue or a pull request. And some more things that we are working on is more dispatchable APIs. I hope you see where I'm going with this. I want to see a world where everything is an API, and people come up to me and they're like, oh, why do I care about this? I'll just use my LLM to write the code, right? Like even with that, like I think an LLM would be much smarter with an abstraction layer, which is controllable. So maybe we can start writing a new layer for plotting. So currently NetworkX has inbuilt plotting that builds on top of matplotlib. It's old code, it works, but maybe we can maybe we can do something with that. And yeah, if you want to get involved, or if you really find this interesting, you can go to this calendar file, and we have like weekly meetings for NetworkX, and also like specifically for NetworkX dispatching, where we talk about all of these cool things. So from going from graphs to databases, now we talk about all. So if you want to jump in, everyone is welcome. And I do want to ask Erik to talk about the backends future.
Oh, the backends future? Yep. Oh, yeah. Like for cuGraph, like we already have the existing cuGraph library that Mridul mentioned. That it uses data frames, in particular cuDF and DAS cuDF data frames, as the data structure. And this library is already very scalable. So if you want to do like a trillion edge graph, cuGraph is probably the fastest thing in town today. And so we want to kind of add this functionality to an cuGraph so there is a story for scalability. And of course, like we're always adding new algorithms. And so please join us at the sprint Monday and Tuesday if you want to talk and learn more. And like if you have a graph.
And also, if there's someone from the other GPU manufacturer, then you can make a backend for this too. Just saying. All right, thank you.
Right on time. So we have time for questions. We also have more content if people want to.
Yeah, we can look at memes if you want.
Yeah. So on the page, the NetworkX page that describes backends, it says they're experimental and likely to break in a future release. Can you say anything at all about when one can expect some compatibility guarantees with them?
Like I think it's experimental in the sense that we can change the APIs. Like for example, maybe we didn't mention that. Like one of the requirements for a backend is that they need to pass NetworkX test suite. So if you're writing a backend, I mean obviously there are probably bugs, but like we try to make sure that there is at least that compatibility. The only thing that could probably break is that we change the name of a variable or like some environment variable. So We hope maybe, I don't have a definite date yet, but yeah, like that's what we need. Like, you know, more usage, and once we know that, then we can try to build towards a more stable release of this.
Great, thank you.
And from my perspective, it's also experimental until we have like just more complete documentation. And even if it's like not going to change at all, we need to better make it usable.
Thanks. I have another question too, since there's no one else at the microphone. So you brought up the idea of rewriting NetworkX in Rust, and then you dismissed it like immediately. But there is a project that has implemented really, I guess, really a significant subset of NetworkX in Rust. So can you comment at all on that different approach?
I guess you're talking about RustWorkX.
Yes.
And yeah, I mean, like that. I think that happened was, it happened when someone was using NetworkX digraph to be specific, and they wanted, like, they really needed speed guarantees at that point, and then, you know, they came up with RustWorkX. Like, the reason I made that joke was that you need people to write Rust. Like, none of the people in the NetworkX code have commit. We are not Rust people. So like someone else can absolutely do this. Yeah. And there is RustWorkX out there, but they don't really promise this notion of, from what I remember, of zero code change. So they have changed the API. So that's the difference. But there are like RustWorkX, and there's also like GraphTool, which is pretty quick and nice if you want performance. But GraphTool also like focuses on very specific set of algorithms.
Thank you.
And also, like, the other thing I do want to show off, because people mentioned documentation. So like if you go on NetworkX doc site now, like we have this additional pop-up, not a pop-up, but admonition at the end, which basically says that these are the backends that also implement this algorithm. For example, in this case, all pairs shortest path length. It will calculate shortest path between all pairs of nodes in a network. And this is implemented by cuGraph, GraphBLAS, and NX parallel. Right? Do we have any more questions?
Thanks for the talk. I'm excited to try out some NetworkX stuff. And I had a question on the benchmarking when you had the warm cache row. I was wondering, was that like an in-process cache or cache to a file and reloaded or what?
It exists in a dict on the NetworkX graph, and so it's just an object in Python. So we convert to the backend graph, and like we save that for future algorithms that may need it. Does that answer?
Yes, thanks.
All right, if there are no other questions, thanks for attending, and see you around.
Thank you.